is limit. See? Okay, 4.1, back to this, maximums and minimums. So here we have critical numbers. Remember that the last thing we left off with from Wednesday was Fermat's theorem, which says that if f has a local maximum min and the derivative exists, then the derivative is 0. So we talked about two things that wasn't saying. And then we talked about what it really is saying, and it's saying that if it's saying that if f has a local max or min, then the derivative is 0 or the derivative does not exist. Okay? Let's actually just write that again. So f has a local max or min implies that the derivative is 0 or undefined. These things are called critical numbers. Did y'all remember when that sign was actually called a pound sign and actually stood for number? This isn't hashtag S. This is numbers. Did you even know that this ever existed?
Yes. I've never asked the ultimate version of it. I've never said that. Maybe that S is sharp.
Could be. Okay. I didn't know you were musically inclined.
Oh, okay. One time.
And you didn't sing for us the other day?
Oh, no. We don't sing now. No. Okay, so one time we were in choir, and everyone was like singing a little under the pitch. Like, wow, we could use the pitch of that. It was funny.
That's pretty funny, actually. Okay. So here we go. These are critical numbers. Values of x. So if we were going to write this out, it would be values of x for which f prime of x equals 0 or is undefined. Critical numbers. Now, because the derivative is 0, does that mean it's a max or a min? No. Because the derivative is undefined, does that mean it's a max or min? No. No. So these don't indicate that there are extrema here, but these indicate possible places that extrema could happen. Extremas are not going to happen unless the derivative is 0 undefined. So it narrows it down from looking at, I don't know, infinitely many things to looking at a finite number of things. Let's try to figure this out. Make sense? Okay, for example, f of x equals x to the 3/5 times 4 minus x, and we want to find the critical numbers. Can you all see this okay, or do you want to zoom? Okay. Okay. I wish it's actually going to change it. I just thought I would ask you and make you feel good. I'm kidding. It was a joke. Okay, here we go. So how am I going to do this? I need to find the derivative. Do you want to multiply this out first? I don't think I ever have, but we can. No, you don't want to? Product rule it is? Okay. First times the derivative of the second plus the second times the derivative of the first. In case you didn't know, it's really hard to tell where the derivative is 0 looking at this. Do you agree? So let's make it nicer. I'm going to factor out x to the negative, let's factor out actually 3/5 x to the negative 2/5. So from this term right here, what do I have to add to x to the negative 2/5 to get x to the 3/5? Negative 2 plus what gives you 3? 5. So x to the 5/5, which is actually already, just known as x. Okay, so negative x. Well, actually, it's not true. Negative x, but I have this 3/5. So what do I have to have here? 5/3. Plus, now what's left over here? I actually took this whole term out, so just 4 minus x. Okay, if we do a little bit more work on this, we have, let's see, 5x to the 2/5, 3 times 4, and then negative 5/3 x minus x gives us negative 8/3 x. And I'm going to leave it like this on purpose. Okay, where's this thing going to be 0? If it's a fraction, where is it going to be 0? When the top is 0. So I'm going to take 8, well, actually I'll just go ahead and multiply it out. So 3 times 4 is 12 minus 8x equals 0. Subtract 12, divide by 8, we get that x equals negative 4/3. No, positive 4/3. Yes? No? Where is it at the front? Where is it at the front? When the bottom is 0, so x equals 0. Now, good. Those are our critical numbers. X equals 0 and x equals 4/3. And we're not actually taking this any further yet. We're not actually checking to see if it's a max or a min or anything. All we're trying to do is find the critical numbers. What'd you say? Yeah. Yes. Are we good? Let's do one more example. Okay, so we're finding the critical numbers. We need the derivative again. So the derivative here, product rule. First times the derivative of the second. Okay, the derivative of the second is stuffed to the one, or the second is stuffed to the 1/2. What do we do with that? 1/2 stuffed to the negative 1/2 times the derivative of the stuff. But what is the derivative of the stuff? Just 1. Plus the second times the derivative of the first. Okay, so again I'm going to factor. I'm going to factor out 1/2 x minus 2 to the negative 1/2. Okay. Left I have x in the first term. Plus, now, if I took out 1/2, what am I going to have here? 2 to simplify with the 1/2. See, if I think about it, if I multiply it back out, I get that term. If I multiply this back out, I want to get just square root x minus 2. So I need the 2 to offset the 1/2. Make sense? Okay, and then this is x minus 2 to the 1/2. This was x minus 2 to the negative 1/2. So what do I have to add to negative 1/2 to get positive 1/2? Just 1. So this is just going to be plus x minus 2. Okay, that's going to give us 2x on the top, but I already have this 2. So that's just going to be x over x minus 2 to the 1/2. Okay, so we have x equals, it's what? What'd you say? And what'd you say? Okay, x equals 0 and x equals 2 is what we get, yes? Seemingly so. Is there any problem with 0 or 2?
Yes.
What is it? Okay, if you put in 0 to the original function, we would have square root of -2. So is 0 in the original domain? Can it be a critical number then? No, absolutely not. So this is not a critical number. The only critical number is x equals 2. So you do have to be careful with the domains. The critical numbers have to be in the domain. I'm sure. I agree with you. Okay, now going also back to the notes yesterday, we had, were you done writing? Okay, were you done writing? Were you done writing?
Oh yeah.
Okay. Going back to what we did yesterday, we talked about the extreme value theorem, which says, does anyone remember without flipping back? Think about it, extreme value theorem. No, that's a no for everyone. Okay. Oh no, it's not a graph. Possibly. Keep going. Yeah, Reese, just go back. It wasn't that many pages back. It was from Wednesday. Yeah, what is it? Okay, so if f is continuous on a closed interval, then f has to have an absolute max and an absolute minimum. Do you remember this now? We talked about it. Okay. Okay, good. So, we're going to talk now about the closed interval test. This is also called the candidate test. I used to always call it the candidate test, and so I'll probably call it that more times than I want to. The candidate test. Not. Okay, so the idea comes straight from extreme value theorem. If extreme value theorem says that there has to be a maximum or minimum on a closed interval, the question is, how do we find it? If there is one, can we find it? The answer is yes, using the closed interval test or the candidate test. So for the closed interval test, we're going to test the critical numbers and the endpoints. We're actually going to test them. That's why this is called a test. So think about it. The only places on a graph that has a closed interval, the only places that you can have an absolute max or an absolute min are going to be at a relative max or min. So what we would usually think of as being a little hill or a valley, a regular max or min, or it's going to be at the endpoints. Right? I think we might have talked about this a little bit on Wednesday also. So it's either going to happen at a usual max or min or at the endpoint. Got it? For absolute, yes. Yes. So that's what we're testing. The critical numbers aren't necessarily the places where a max or min happens for sure, but they're the possibilities. So we're going to test those points and the endpoints, and we're actually going to see which one has the biggest value, which one has the smallest value. Okay? Student example. Let's do f of x equals square root 9 minus x squared on -1 to 2. So first we have to find the critical numbers. So we need f prime. Here we have stuff to the 1/2. The derivative of stuff to the 1/2 is 1/2 the stuff to the negative 1/2 times the derivative of the stuff, which is negative 2x. So this is going to be negative x over square root of 9 minus x squared. Where's this 0? What were you going to say? It's okay. We all have those things. The domain. Difference of, okay. It's okay. It's cool. We got this. Okay. So we also see that this is going to be undefined when the bottom is negative 3 and 3. Actually, and all the outsides of that. If it's less than negative 3 or greater than 3. But what is our domain? Negative 1 to 2. So are there any places where the bottom is going to be 0 from negative 1 to 2? No. Okay, so x equals 0 is our only critical number. And now we're going to make a table. Our candidates are going to go in the x column. So our candidates are going to be negative 1, 0, and 2. The critical number and the endpoints. And then we're going to plug them into the original function to find out which one has the maximum value, which one has the minimum. So if we plug in negative 1, we get the square root of 8. If we plug in 0, we get square root 9, and I am going to write it like square root 9 so I don't have to mentally convert anything. If I plug in 2, I get the square root of 5. Okay, so if the question was, what is the absolute max? What is the absolute max? 3. What is the absolute minimum? Square root 5. So remembering that absolute max and absolute min are y values. And here's what we do. We have to take the derivative to find the critical numbers. Then we're going to set up a table where we have the critical numbers and the endpoints. So those are the only possibilities for the absolute max or absolute min. We're going to test them all. And that's going to give us what is the absolute max, what is the absolute minimum. Make sense? Okay. If I said at what x value does the absolute maximum occur, what would you tell me? 0. So just be careful to answer what the question is actually asking. Good? You want to do one more before we leave? Let's try one more. Let's do... You need to find the critical numbers. The derivative is 54 minus 2x cubed is going to be minus 8x squared. Where's the 0? That's what I said. I'm just kidding. I said 8. I don't know why. 2 cubed is 8. That's probably where I got that from. Okay, so 6x squared. It's funny because I worked the entire problem out thinking it was 6 also. So bizarre. So x is what? 3 and negative 3. But what about negative 3? It's not the domain. So x equals 3 is our only critical number. So now we have our table. We have 0, 3, 4. They don't have to be in order, by the way. I just do. 0 is 5. 3 is 54 negative, I don't know. Does someone have a calculator? 5 again? It's 5 plus. Okay, that's okay. So 54 times 2, what's that? 108? Plus 5 is 113. Okay, and 4, what is it? Does anybody know? Okay, you get the idea. Homework's on the grid. Do the homework. Did you turn in your homework from last night? Turn in your homework from last night. Start with 29 on tonight's homework.